promise this is the last presentation I'm going to make today. Yeah, it's kind of when doing the agenda for the workshop, we're trying to follow some kind of logical theme here. And the next step after what I showed earlier about studying those whales populations would be to use part of those results to find possible potential solutions to mitigate depredation. So what I'm going to talk to you about here is how we can combine research based on fishing practices, how to modify the fishing behavior of vessels, of captains, with research on whale ecology to mitigate this issue. So here I'm going to focus on that specific area again, the Crozet, EZ. These are the spatial distribution of all the fishing events that it is since 2003. So you could see that it's close to the island, but also a little bit further west, close to the EZ boundary. And the data we used, and this is how we were actually lucky to have that. It's full access to the fishing data, and this is thanks to the Museum of Natural History of Paris, and we could combine this data with the monitoring of the whale population. And the idea here was to develop those solutions, first using technical approach, and I'm going to say a very few words about that because Marta has already talked about that. And the second one was to focus on behavioral approach. So the first one, technical approach. So Marta has presented everything about AHD, what is already known about these devices. Here are the details of what we actually did of the Crozet Islands. The device, it's the famous Orca Saver, so it's made by a private company in Holland, and these devices have been sold into many fisheries, and one of the boats that is actually operating off the Crozet Island, he did purchase one of these devices that was in 2011. And what we wanted to do is to develop a real protocol to test if the system is actually efficient or not in repairing the whales. What we did was to measure the distance of the whales from the vessel, assuming that if the system would work, they would repair the whales far away from the vessels, so far that they could actually stop interacting with the fishing gear. So with an observer, we measure the distance from the vessel by activating or not activating the Orca Saver. And these are the results. The first graph you see at the top is the distance of the whales when the system is being activated. And on the x-axis at the bottom, you see the successive activation events of the Orca Saver. So you see that at the very beginning, the whales do react to the device. They kind of flee. They go away from the vessels so far that they can reach distances of more than 1 kilometer away from the vessels. So basically, they stop interacting with the fishery. But that was only on the first exposure. That's the only event. After that, what we see is that the same whales, they stay around the vessel, and progressively they get closer and closer to the vessel until reaching exactly the same distances than if the Orca Saver was not activated. So that was interesting to combine those data with the photo identification data. We monitored 2 groups of killer whales, and both of them had the same trend. They're all habituated to this new system. And you can see the graph at the bottom here. It's the range in terms of distance between activation and non-activation of the system. So yeah, clearly whales do habituate to the system, and it goes further than that. If other whales come in, and this is what we have been observing as well, and they associate with whales that have already been exposed to the system, those whales are going to habituate extremely quickly just by looking at the other whales who already know what's going on with the Orca Saver. The motivation of depredation is so high that those whales, they're going to go through this potentially painful hearing effect on them. And what we don't know is what Marta has been talking about is the long-term effects of such exposures to such AHDs. So the main part of the work we've been doing was on the behavior of vessels. This is a graph showing you the differences in terms of interaction rate with whales between the 7 vessels of the fishery. And what is interesting is that you get great variations, that some vessels get very high interaction rates, some others are doing better with lower interaction rates. What we wanted to do is to examine a number of different variables that could explain those variations. And this is what we call operational variables. This is what can be controlled by the captains. And the first one was the length of lines. What we assume is that shorter long lines may prevent killer whales from depredating great number of hooks. And this is especially the case when a vessel is operating on a fishing ground, no killer whales around, but when the killer whales get onto the fishing ground, they're going to save more hooks and more fish. The second one was the hauling speed. What we assumed was greater speed may reduce the number of fish removed within, well, that range may be different now with the new data, but because the killer whales have limited diving abilities compared to sperm whales, they're going to be able to access the fish only into depth range that is actually limited. So they have to wait for the vessels to haul the line aboard to be able to access the toothfish. And if you increase your speed, you may prevent killer whales from removing a lot of fish. And the third one was the distance travel between fishing grounds. We all know that the killer whales do follow the fishing vessels, and, but they move slower than a fishing boat. What we wanted to know if at what distance they can lose a vessel. And this has great implications in terms of advice you can make to the fishery when trying to lose the whales. So these are the results. We actually find negative effects of the length of long lines. The shorter your long line is, and actually under 5,000 meters, the better is the CPUE. And this is especially significant when the whales are not on the fishing ground yet and arrive during hauling events. The second one, hauling speed, we did find a positive effect of hauling speed. When the whales are already interacting with a fishing boat, if you increase your hauling speed, you're going to save more fish and increase your CPUE as well. And what we found out is that you got this threshold of about 50 hooks per minute for which whales can't follow. They're going to be able to grab some fish, but not all of them. And the third one was the distance travel. What we found out is that with very small distances between fishing grounds, whales are going to find the vessel again very, very quickly. Within hours, if the vessel switches from one ground to another, you get the same whales following the vessel. But if you move further, for example, from 100 kilometers away from a fishing ground, then the probability of having the same whales is much lower. And that leaves about 2 or 3 days to the captain to operate without those killer whales. So this is just a summary of these 3 operational variables. What we did was to convert those results into recommendations. That was back in 2009. So the captains would be able to test it and to try it in real sea conditions. And those were the first results we had. We saw that some vessels did respect all those recommendations. They had some, positive effects on CPUE interaction rate. Some others did not really respect those recommendations. The effects on interaction rate were negative. Greater interaction rate, lower CPUE. This is very preliminary. We wanted to go further into that, and I'm going to talk to you about that a little bit later. Then, how we can use what we get in terms of knowledge on the whale populations. There are 2 aspects that actually can be used by the fishery. The first one is seasonality, and the second one is distribution. Where are the whales? Where are they feeding naturally? So that is in terms of distribution. These are the variations in space of the interaction rates, the percentage of depredated sets. There are areas, hotspots of depredation, and what we want to do is to advise the fishermen to avoid those areas. Most of the skippers, they already know what kind of area is going to be hard because of depredation or not, but the problem is, especially for the killer whales, let me get to that slide, is that there is a positive relationship between the interaction rate of the killer whales with the productivity, I mean the richness in terms of toothfish of the area. Whales are already on grounds with high fish production. So it's a possibility that those whales already know, I mean just like fishermen, those rich fishing ground. We also examined the variations of the number of killer whales, and it was kind of good correlation between those hotspots of interaction rate with the number of killer whales per depredation events. So that is a mean, an average of the number of killer whales and sperm whales when they are depredating. And in some areas, on average, you get more than 5 killer whales. That's an average. So that means there are a lot of them. Sometimes it goes up to 25. And those are also areas that are to be avoided by fishermen. Seasonality, I talked about that earlier today. We detected some decrease in terms of the probability of interaction with killer whales during specific period. This is between October and December. And same thing with sperm whales. Because of their ecology, sperm whales do migrate from those feeding grounds where they interact with the fisheries to those reproduction grounds. And this is especially during winter months. So during that period, yes, you have lower probability of having sperm whales around the fishing vessel. And then I'm going to talk to you about an ongoing study, something that we are doing with a PhD student that just started this year. And this student has started to look into not the vessel behavior, but the captain behavior. This is a graph that is showing you different captains using the same vessel. And at this level, you can actually also see differences in terms of probability of having depredation. Same captains, same vessel, so that rules out everything that is related to the vessel features, but it's really about behavior, how those skippers use the vessel. This is just an example of how a fishing vessel with one captain is going to forage, look for fish and fish around the crozet area. He's going to go for one spot and then move to another area. Yeah, sorry, it's not very clear here. It's going to work for a few days and then move to another fishing ground and then keep moving like this. We actually based this study under the theory of optimal foraging. That is, the fisherman wants to maximize his CPUE, right? And what we analyzed was what is going to influence the decision making here. The fisherman has two decisions to make. The first one is to stay. This is a good fishing ground. I'm going to remain into the fishing ground. And the second one is to leave, and for whatever reasons. And this is what we are interested in. Is it because of CPUE, or is it because of the whales? What we observe is that between skippers, we've got totally different strategies. Basically, they all decide to leave or not to leave under the same level of CPUE. This is what you see at the bottom axis here, the total weight of toothfish per day. Some skippers are going to leave more easily, the fishing ground if the CPUE is not good enough, and others are going to remain into that area. And we did detect an effect of the number of killer whales here. So basically, there are two main drivers. It's not really the presence or absence of killer whales driving this decision. It's primarily the CPUE, that's for sure. If the total weight of tooth fish per day is good enough, even if there are killer whales around or sperm whales around, the captains are going to stay into that area. But if the number of killer whales increased, then there is higher probability of the captain of making the decision. And the last results we are actually getting right now is how those variations of efficiency between skippers can be explained. And what we did was to test those initial variables we've been looking at: long line length, hauling speed, depth, and another one, which is the experience of the skipper. And all these 4 variables did explain why some skippers were doing better, even if they were depredated, or they were doing better because they were able to better avoid depredation. So, yeah, it's just a case study, I would say. It's interesting because you got the data to show that for the Crozet Islands. I'm hopeful in discussing with you guys if those different variables can also be applied to other fisheries, and what conditions and how they work, and if it's possible to move forward with these variables. Thank you.